All right, so we're carrying on with lecture 7. Lecture 7 focuses on regular expressions. So regular expressions, we're going to cover case sensitivity, cleaning up user input, and extracting user input, and then summing up. So regular expressions or regexes will enable us to examine patterns within our code. For example, we might want to validate that an email address is formatted correctly. Regular expressions will enable us to examine expressions in this fashion. To begin, type code validated.py or make a new file in the terminal window, encode as follows the following. So I'm going to just do this here. I'm going to say email equals input. What is your email? Let's just first try that before I write the file. And if I want, John@gmail.com. Okay, that's just the basic input. But now we want to make it a bit more involved. Add this if statement to check if the @ symbol is in email. So let's get the code. Put the code over there. Okay, all right. So let's just try it again. David. So it checked the if condition and says yes, @ is in email. Notice that strip will remove white spaces at the beginning or end of the input. Running this program, you'll see that as long as @ symbol is input, the program will regard the input as valid. You can imagine, however, that one could input 2 @ symbols alone and the input could be regarded as valid. You could regard an email address as having at least one @ and one dot somewhere within it. Modify the code as follows. So effectively, we're going to just check 2 conditions. We'll say check if @ is an email and dot is an email. We're using the AND operator. David@gmail.com is valid. Let's try it again. Start maybe removing David. Invalid. I replace with an exclamation mark. So let's try again, maybe with like a comma, maybe. It's invalid. Both the and @ and dot needs to be there. Notice that while this works as expected, our user could be adversarial. Typing simply @ dot would result in the program working. So let's try that. @ dot. So it's valid, but obviously not right. We can improve the logic of our program as follows. We can say user dot domain email dot split with and. So we are making this a bit more advanced. We first saying the email must be this format. And we're going to find the @ symbol and split it a username and domain. And then username must have a dot symbol in it. Username must have a dot in the domain. So let's try this loop. So let's try David@gmail.com. Works. Okay. Selected. What about @ and dot? Invalid. That is invalid because it looks for it's split this. Let me actually put it out so you can see what username looks like and what does domain look like. Print if it's the username. And domain. See what that looks like. Anyway, there we go. Gmail. If okay, doesn't actually want to use printf. Oh, so it's just doing something. There we go. So what this splits it up as David and gmail.com. And now it says if username is true and dot is in domain, which it is, then it'll be true. So we can try that edge case f dot, say it is invalid because we don't have any username or dot in that, so it's invalid. Notice that our strip method is used to determine if username exists and if dot is inside the domain variable. Running this program is standard email address typed in, or you could be considered valid. Typing in, for example, this one alone, you'll find it be invalid. Let's try again. For example, this is the one we have, and the other one was David at gmail.com. So this example should fail. It fails because there's no dot. You can't find dot in domain. So we can be even more precise, modifying a code. We can say it can maybe be specific. Be more specific. Maybe we're looking for specific domain. We're looking for a specific domain that it ends with .edu. So let's try that one, for example. This example we're going to use over here. This is valid because it ends .edu, but the dot is not correct. So which is a bit of a problem. So, however, a nefarious user could still break a code this way by saying .edu, and it would be considered valid. Indeed, we could keep iterating upon this code ourselves. However, it turns out that Python has an existing library called RE or Regex that has the number of built-in functions that can validate user inputs against patterns. One of the most versatile functions within library RE is search. And the search function allows a signature search with the following: pattern, string, and flag equals 0. So following the signature, we can modify our code as follows. So we can, let's get this new code over here. Okay, well, let's just leave it as is actually, and just comment that out. Comment this stuff out over here. Or let's maybe just a new lot of code over there. So this imports the library for regexes, gets the email address, and search. Does it have an @ symbol? So we can try that out now to see if there's a. So just to repeat, we are using this code over here to check if the email address will work. So if we can run it, we can say, for example, this one works. That's fine. How about this one? Works. It's okay. And now let's just test the edge cases. I'll say dot. Also works. So this is a problem. We have to, make sure that doesn't work. We can further we can further our program's functionality. However, we need to advance our vocabulary around validation. Turns out that in the world of regular expressions, there are certain symbols that allows us to identify patterns. At this point, we have only been checking for specific pieces of text, like the @ symbol. It also so happens that many special symbols can be passed to the interpreter for the purpose of engaging validation. Non-exhaustive list of those patterns is the following. So dot is for any character except a new line, star, 0 or more repetitions, plus 1 or more repetitions, question mark, 0, 1 repetition, curly brackets m repetitions, curly brackets mn, m to n repetitions. In implementing this code, let's see what you can do to get to modify your code as follows. So we're going to just modify this line over here. we're going to say expect any character. We're gonna expect any character before, so that's a dot. And it can be +1 repetition, and then expect any character after dot, and expect 1 or more repetitions. So let's try run this now. So that should work as is. How about this one at dot? This is invalid because it did not find any character after the dot symbol. Notice that we don't care what the username or the domain is anymore. What we care about is the pattern. +dot is used to determine if anything is the left of the email address and if anything is the right of the email address. Running your code, typing in line 8, notice that the input is regarded as invalid, as we would hope. Had we used a regular expression .star at .star in our code, we could visualize as follows. So let's try this one maybe. That would be star stands for 0 or more repetitions. So we don't want 0 or more repetitions, we want 1 or more. So let's try that. Let's do the example we had here. That's valid. So at and dot, also valid. So that won't work out because it's 0 to 1. We want at least 1 repetition. So let's add the plus symbols back. And then that would invalidate that for us. Notice that when we don't care what that is, running your code is as follows. How do we use this expression? You can visualize as follows. So start at this state, check for at, and completely repeat until we find something. Notice the picture on the state machine of our regular expression. On the left, the interpreter begins evaluating statement from left to right. Once we reach Q1 or question 1, interpreter reads time, a time again based on the expression handed to it. And the state is changed looking now at Q2, or the second question being validated. Again, the arrow indicates how the expression will be evaluated time and time again based upon a programming. Then, as depicted by the double circle, final state machine is reached. Considering the regular expression we use in the code as follows. Dot plus at dot plus. Can visualize that as follows. Notice our Q1 is any character provided by the user, including Q2 as 1 or more repetitions of the characters. This is followed by the at symbol. So again, just to specify, the plus can be any character. So any character can be repeated 1 or more times. Star is 0 or more repetitions. So any character doesn't have to be repeated or can be. So plus is more specific, has to be at least 1 character or more, and it can be repeated like 2 A's, 1 A. It will accept it. This one is like if no character, it can be anything. So again, the arrow indicates, if we go back here, the arrow indicates how the expression will be evaluated. So considering the regular expression with dot plus at dot plus, you can visualize as follows. Notice our Q1 is any character provided by the user, including Q2, as 1 or more repetitions of the character. This is followed by the at symbol. Then Q3 looks for any further character provided by the user, including Q4, as 1 or more repetitions of the characters. The RE and RE.search functions and ones like them look for patterns. Continuing our improvement of this code, we could improve our code as follows. Let me just comment it out so you can just have a reminder of what it looked like before. So now we are going a step further. We are looking for .edu after that. This is the new pattern we are looking for. So for example, we had David. This would be invalid because it's looking for something that ends with .edu. So I can maybe try an example here. .edu. This again, this is valid. Notice, however, that one could type this and type in, and it could be considered valid. Okay, let's try that example. This test case. for a question mark .edu because it's valid. Because it looks for anything that comes .edu. Let's maybe copy this case over there like that. These are our test cases. So why is this the case? You might recognize that in language, a validation, a dot means any character, not the actual dot itself. So we can modify code as follows, and we just use a backslash dot to specify the actual dot character. So with a backslash dot, then should work. There's just a warning. I think it should still work. Or not. Let's just see if it still works. That is valid. What about this one? I think this is just a warning. Can just ignore it. It is invalid. So I was able to search for that correctly. All right, so what does this warning refer to? All right, to fix this issue of that warning, you can because Python sees backslash as a specific Python interpreter as something else. If you add an R in the beginning, you won't get the warning anymore. So the warning is gone. So let's check that again. It's invalid, and this one should be valid. Cool. Notice we utilize escape character or backslash as a way of regarding the .e as part of our string instead of our validation expression. Testing your code, you'll notice that this one works, is valid, and this one is invalid. Notice that we're using escape characters. It is a good time to introduce raw strings. Python raw strings are strings that don't format special characters. Instead, each character is taken at face value. Imagine \n, for example, seen in a lecture how in a regular string, these two characters become one, a special new line character. In raw string, however, \n is treated as not as \n, the new special character, but as a single backslash and a single n. Placing an R in front of the string tells the Python interpreter, treat the string as a raw string. Similar to how placing F in front of string tells Python interpreter to treat the string as a format string. And here's an example that we are referring to. Now they put a $ symbol because we haven't dotted $signs yet. Okay. So this is the R in front. Now we've ensured that the Python interpreter won't treat \n as a special character by placing R in front. Said simply as followed by dot, which in regular expression terms means matching a literal. You can imagine still how our user could create problems for us. For example, we could type in a sentence such as my email address is this following, and the whole sentence would be considered valid. To be even more precise in coding, I can maybe add this just to see. It is valid, which is obviously not correct. Now the notes doesn't explain the $sign yet. Invalid. So what does the $sign do? Just so happens that we have more special characters at our disposal. This symbol matches this power symbol matches the start of the string. A $ matches the end of the string or just before the new line at the end of the string. So we can modify the code as follows. Notice that we've added a $sign at the end. Notice that this has the effect of looking for this exact pattern matching to start and end of the expression being validated. So this starts with this over here, ends with that pattern. So this specifies this is what start and the end should look like. And this is what these two symbols mean, and this is what the code was done before. So by adding this over here, beginning and end, this specifies that this would not work because it's looking for the exact match. We propose we can do even better, even though we are looking now for the username at the start of the string, the @ symbol, and the domain name at the end. We could type in as many @ symbols as we wish. For example, this one. Let's try this use case. And let's try, for example, this use case. I think this one would still be valid. Let's have a look. We can add to our vocabulary as follows: is square brackets is a set of characters, and square brackets with the power symbol complementing the set. Using these newfound abilities, we can modify our expression as follows. We can put square brackets around here and here. Notice that the power means to match at the start of a string all the way to the end of expression. The dollar symbol means to match at the end of string. This symbol with this square brackets power @ plus means that any character except an @ any character except an @. So this just means that we're only looking for one @ symbol. Then we have a literal. So this is for an exclusion. This is for an exclusion. Then we have a literal. @ means any character except an @ followed by an expression. So again, we're excluding this @ and this @ over here. Typing, and now the following would regard it as invalid. Let's have a look. It's getting quite messy now, so let me just comment it out so you can see the changes as we go along. Not rejected. So just note the difference that we had here. This stayed the same. And then we added this search pattern, which tells Python it cannot have an @ symbol. All right, it cannot have an @ symbol. And this looks for the @ symbol, and this says afterwards it cannot have an @ symbol. And then this looks for the anything that has the .edu at the end of the string. We can still further improve this regular expression further. It turns out that there are certain requirements for what an email address can be. Currently, we are validating expression is far too accommodating. We might only want to allow for characters normally used in a sentence. To modify this code as follows. So let me just copy this to see the changes. So just do that, comment that out. So now we are, instead of saying do not use the @ symbol, we're saying anything between any letters and numbers between an underscore can be full @ symbol, and any letters and numbers after can be used over there. So that should also work. I think this is not indented. There we go. So this tells the validation that characters must be between A and Z, between A and Z, between 0 and 9, and potentially include the underscore symbol. Testing input to find that many potential user mistakes can be indicated. Thankfully, common patterns have been built into regular expressions by hardworking programmers. In this case, you can modify code as follows. This looks a bit easier to understand here. This one. So notice that \w is the same as saying this over here, thanks to hardworking programmers. Here are some additional patterns we can add to our vocabulary. \d is for decimal digit. Big D is not a decimal digit. S is whitespace characters. Big S is not a whitespace character. W is a word character, as well as numbers and underscore. Big W is not a word character. Now we know that they are not simply .edu email addresses. We could modify code as follows. We can include these examples as well. So we can include various other examples. Notice that the symbol over here has an impact of an or in our expression. And even more symbols to our vocabulary, here are some more to consider. A, either A or either B. This refers to a group. This is the question mark is for non-capturing version. Case sensitivity. To illustrate how you might address issues around case sensitivity when there is a difference between edu and edu and the like, let's rewind our code to be followed. So let's just try out the code, see if there might be issues with that. So let's just make it edu. Okay, that's still quoted as invalid because it didn't find the edu over here. Notice that we have removed the or, the symbol or the typing symbol previously. Call that within search function, there is a parameter for flags. Some built-in flag variables are the following: ignore case, multi-line, and do all. Consider how you might use these in the code. For example, the following. So what does this do? Now we've added a third parameter for ignore case. Running the program, for example, this one over here, input is now considered valid. Because we have not ignored the case. Consider the following email address. Using our code above, this will be considered invalid. And why might that be? Let's try that again. Invalid. Since there is an additional dot in the program, this considers it as invalid. Remember this is the dot we are referring to. It turns out that we can look at a vocabulary from before we can group ideas together. We can modify code as follows, as shown. Notice that how this pattern over here communicates to the interpreter that this new expression can be there once or not at all. Hence, both this and this is considered valid. Interestingly, though, the edits we have done so far to our code don't fully encompass all the checking that could be done to ensure a valid email address. Indeed, there's a full expression that one would need to have to type in to ensure that a valid email is inputted. This over here, there are other functions within a library you might find useful, which is match and full match, are the ones you might find exceedingly useful. You can learn this more about the Python's documentation. Cleaning up user input. Should never expect users to always follow your hopes for clean input. Indeed, users will often violate your intentions as a programmer. There are always ways to clean up your data. In the terminal window, type a code format of py, then in the text editor, the following. All right, so that's another. Well, let's first do this format.py. So let's have a look. So in the terminal window, type code format.py. Again, we can do that. We're just going to use an extra block, make our lives simpler. So we can type the following. We take terminal window, do the following. Notice that we have recreated essentially a hello world program. Running this program, typing David, it works well. However, typing in Malan and David, notice that the program does not function as intended. How could we modify our program to clean up this input? So modify the code as follows, where we check the if statement, then this is last and first, split that, and then print out the output we are expecting. So Malan and David. Notice how last first name split is run if there's a comma in the name. Then our name is considered as the first and last. Running our code, typing Malan David, you can see how this program does clean up at least one scenario where a user types in something unexpected. You might notice that not typing in Malan David with no space causes the interpreter to throw an error. Since we know some regular expression, for example, let's just see, type it in. David. Yes, it is error because there's a space. It cannot unpack that. It must be a space. So let's apply some code to look at a space. So matches. So we find a start and end. So that's what we have here for the pattern. We're finding something before comma, something after comma. And if matches, if this is true, then last and first, we're going to split it into groups. Name first, plus last. Let's see how that one works. And David. Look if it works. Notice that our research can return a set of matches that are extracted from user input. Matches are returned by research running this program, typing in David Malan. Notice how the if conditions are run and the name is returned. The run program by typing Malan David, the name is also returned properly. This happens that we can request the specific groups back by using matches as a group. We can modify the code as follows. By specifying the amount of groups that you want as well. Match group 1 and match group 2. Notice how this implementation group is not plural, there is no groups. Our code can further tighten as follows by updating the following. Just note that group 2 and 1 are concatenated with a space. First group is that which is there for the comma. The second group is that which is with the right comma. Recognize still that typing Malan David with no space, it will still break the code. Therefore, we can make the following update. Update the regular expression this way. Notice the addition of the star in our validation statement. The code will accept and properly process Malan David or comma David. Further, it will properly handle David Malan, but many spaces in front of David. It is very common to utilize our research as we have in the previous examples. The matches is on line code after that. However, we can combine these statements. As you can see, we've combined these two statements. Notice with the notice that how I combine the two lines of code with the walrus. So operator assigns a value from right to left and allows us to ask a Boolean question at the same time. So this is the walrus. Turn your head sideways and you see why it is called a walrus. You can learn more about Python documentation from RE. Link over here. So far, we have validated the user's input and cleaned up the user's input. Now let's extract some specific information from user input. In the terminal window, type the following. Twitter.py and code as follows in text editor. So we're not going to create a new file, we'll just use it as is. Let's over here, let's see what we got. And this is the one we're going to use. It shows exactly what the user typed. However, we may be able to extract just the username and ignore the rest of the URL. You can imagine how we could simply be able to get rid of that beginning and I'll send Twitter URL. We can implement as follows by using a replace command over here. URL. And we get the username. Notice how the replace method allows us to find one item and replace with another. In this case, we're finding part of the URL and replacing it with another, or with nothing. Typing in the full URL, the program effectively outputs a username. However, what are some shortcomings of this kind of program? What if the user simply typed twitter.com instead of including HTTPS and the like? You can imagine many scenarios where the user may input or neglect to input parts of the URL that would create strange outputs by this program. To improve this program, we could code it as follows by using remove prefix. To get it correctly out. Regular expressions simply allow us to succinctly express the pattern and goals. In our library, there is a method called sub. This method allows us to substitute a pattern with something else. The signature of the sub method is as follows. The pattern, what you want to replace, the string, the count and flags. Notice how pattern refers to the regular expression that we're looking for. Then there's a REPL string that we can replace the pattern with. Finally, there's a string that we want to do the substitution on. Implementing this method in our code, we can modify as follows. Notice how executing the program and putting this produces the correct outcome. However, the problem is still present in the code. Protocol subdomain and the possibility that the user inputted any part of the URL after the username and all reasons that the code still not ideal. Further addresses shortcomings by further using some commands as follows. Let's go back to the code here, for example. So these are just cases where edge cases we want to try and fix. Notice how the carry or the powers carry was added to the URL. Notice how the dot could be interpreted improperly by the interpreter. Therefore, we escape it by using the backslash to make it backslash dot. For the purpose of tolerating both HTTP and HTTPS, we added a question mark to the end of HTTPS, making this S optional. Further to accommodate www and www /dot to our code. Finally, just in the case we user decides to leave out the protocol altogether, the HTTP :// or the following is made optional. Still, we are blindly expecting that the user input a URL that indeed has a username. Using our knowledge of research, we can further improve our code using groups. Where is it? Where's the URL now? So on. Notice how we are searching for the regular expression above the in string provided by the user. Particularly, we are capturing that which appears at the end of the URL of the regular expression. Therefore, the user fails to input a URL without a username, no input will be presented. Even further tightening our program, we can use the walrus again. Notice that this tells the interpreter it does not have to capture what is in that spot in a regular expression. So we can be more explicit to ensure that the username input is correct. Using Twitter's documentation, we can add the following to our program. There we go. Well, this is what you're adding based on Twitter's program or documentation. Notice that these tells the interpreter to only expect these letters, numbers, and possible underscore as part of the regular expression. Plus symbol indicates that we are expecting one more character. You can learn more about this in Python's documentation. Summing up, we have learned a whole new language of regular expressions that can be utilized to validate, clean up, and extract user input. Regular expressions, case sensitivity, cleaning up user input, and extracting user input. Great, thanks so much. Until next time, goodbye.